暂停掉吗？需要暂停吗？
不是，你现在去讲也 OK 啊，我都 OK。
而且你现在上面也是 OK 的。
没有我的环境，还是好的呀。最好是做一个广告嘛。
我只是一个简单的广告。
但是我们1点半
需要现在介绍。
对，1点半是要讲的。
陈老师，不是你到底几点开始？我说一直在说着，我听你说要2点开始，那2点开始我就走了。对，你不是1点半。
是这样子的，就是我们是1点半开始讲这个，然后2点半现在在走这个。
那1点半也没有什么，
现在就是上去。
对啊，可以让他翻跑。我看着你们打比赛的时候，到底几点了？现在我有时候我要去记，
要不就这样，直接就把那个 link 打开就行了，就把那个 link 打开，然后。
Yeah, our workshop will start at 2 o'clock, but we still have 15 minutes. So I want to use this time to let us to know that actually today we will launch a 24-hour hackathon. Yeah, and this hackathon is to do the kernel development. So here is actually the link to start this competition. We have totally 24 hours, and you will see we actually already launched the track. We have 3 tracks here, and any of you can select any track you want to compete for. Don't worry about if you are not the algorithm expert, you might not understand what exactly this algorithm looks like, because we will allow you to use the large model, especially we also have the KernelGen, that is the agentic system to automatically generate a kernel in high performance. So you can use these kinds of model, the tools or any other large model to participate in this competition. And we actually have this competition for both offline and online. For the offline, that means that it is all the developers today in GOSIM can participate this one. Just mark you are offline, then you will have the chance to compete for the prize, and we will deliver and we will announce the reward in tomorrow's closing ceremony. Tomorrow it will be around 5 p.m. tomorrow in the closing of the GOSIM. And the organizer together with us, we will announce who will be the winner for this competition. And we allocate a dedicated prize for all the offline developers. Meanwhile, we also launched the online, the global competition. That means that no matter currently you are in Europe, you are in China, you are in Asia, or you are in US, or you are in any place in the world, you can participate on the online competition. Again, also the 24 hours, we will get a top winner for different track, and we will have the reward for each winner for the cash. So that means that for the developer here in GOSIM, you will have a higher percentage to win this. Don't need to compete with the global. You just compete with the local offline developer. So you will have a higher probability to win the reward. Okay. So. Any questions? Actually, okay, sorry. Actually, in today's workshop, we will have Dr. Tao Jian. He will introduce our KernelGen, that is the agentic system to do the high performance kernel generation. He will introduce that tool and the technology behind that tool. So you can better understand how to use that tool to very easily participate in this competition. And also, he will also introduce more detail about the competition. So now you can try it, sign up for this competition, and this afternoon you can get more first-hand information about how to participate in this competition. Any questions? Sorry, we haven't started the workshop yet, but I just want to use this time to warm up. Yes, I don't know. Good question. Where to log in? Should we log in, sign up for the account, right? 要 sign up 了，是吧? Okay, just go to the.
Use your email. Use your email to.
Yeah, so. Good question. 有没有二维码？大家一扫就可以。
报名吗？
对呀。Good. This is our first time to have this global competition of 9. So, yeah. So you help us to run the. Yeah, we actually prepared the QR code. KernelGen.FlagOS.io, or just go to the FlagOS.io. Please see if you. Of course, this afternoon is not only for this competition. We have prepared a lot of very important, high-value topics. This competition just one of that. 那个齐章啊，那个链接。
Good afternoon, everyone. Welcome to GOSIM and welcome to our forum of Open Compute for Agentic AI. At yesterday's AI Vision forum and this morning's forums, we have got a lot of information. And one idea has become increasingly firm in our minds that no matter how rapidly the world is changing, and no matter the devices, issues occurring in the world, but open source and openness is very key to this challenge. Open compute is based on this idea from the first our participation of GOSIM last year, and this year we have made more progress. For example, our China-Africa Education Cooperation Plan has finished the first phase, and we have 11 teachers come from 11 African countries graduate last week. And also our open source plan, Eval, announced in the Eclipse Foundation, OCX, last week. So, and we have seen not only the open compute idea, we also stepping into open open evaluation and open governance. So actually, we anticipate more to happen in GOSIM as we are collaboration and innovation more to come. Before the first topic, I would like to promote that our 24 hours challenge, KernelGen challenge. You can see this URL KernelGen.flagos.io. Yeah, you can see the challenge button on the top. Yeah, this is a 24 hours challenge we have started, and we will have the offline challenge here, and the winner will get his award tomorrow at 5 o'clock in the afternoon. Yeah, this is our website. Welcome to join. And then let's welcome our first opening session, VP of BAI, to share with us the open compute idea. Yeah, welcome.
Okay, thank you. Yeah, for this challenge, just ensure that you need to sign up, then participate. Okay. Okay. Since this is the opening speech, so I want to introduce this workshop, Open Compute for Agentic AI, especially the why FlagOS is very important to support this open compute for Agentic AI. So actually, I think in my talk and also the talk in this afternoon, you have a lot of very distinguished speakers. We want to have 3 questions to discuss today. What kinds of compute infrastructure will be required by the Agentic AI? How open source community can build it together? And also, how do we do the evaluation, governance, and deploy the agentic system in the real world? Okay. But again, since just now the open challenge for the challenge hackathon, the URL is too small. I also paste the larger URL here, and if you need, just take the photo for this URL, and then you can sign up to participate the hackathon. Okay. Actually, we can see that for the Agentic AI, it really creates a new computation patterns. One is the thinking workload, the model to support this thinking, the workload. It is long context reasoning. It is the multi-step to do the true calling, and also it will require the persistent memory. On the other hand, the execution, the runtime to support each agentic system, the execution runtime, it needs to support the code execution, and we also need to do the evaluation in the real environment. It's unlike the large model evaluation. We prepare the 100 or 500 question and answer like MLU, those kind of things. It's not like that. For the agentic AI, when we do the benchmark or evaluation, it needs to finish the real world problem or solve the real world problem. And always on the inference workload, okay? So that's why we say the model inference becomes the runtime of intelligence. And why open compute is so important for agentic AI? So on the left-hand side, I prepared a table for you. Actually, just in the past 4 months in 2026, you can see all these newly released foundation model from the different model, the large model team. So a lot of very familiar big name here: DeepSeek, Qwen, Google, Mini CPM, Kimi, and Minimax, and others. Okay, Hunyuan from Tencent. Okay, so all of these very important models just released in the past 3 or 4 months. So with this very outstanding or frontier model, we need more chip to run this model on different systems. We do need more compute resource. So we do need more chipsets in the world. If we can run them on different chipsets, that means that we can have more choice. Developer, you can have more choice to select which is the right hardware, or cheaper hardware, you can deploy that, so that it lower our cost, okay? So that means open compute, really it is to allow our AI algorithm or AI model to run on different hardware, okay? That is the open compute. So if you help us to turn the open weight model, this model, when they do the open source, is not really open source the code. It is to open source the weight files, okay? So to turn this open weight model into the real deployment choice. Okay. So I want to use the DeepSeek version 4 as example, because this is just the latest, very outstanding open source model released in last 10 days, okay? And we do think that why we use the DeepSeek version 4, because it has a lot of breakthrough, not only for the model's performance, but for the efficiency of the system. It creates a lot of breakthrough. So first, of course, why DeepSeek V4 matter for the agentic AI? Because it provides 1 million the context length, 1 million the token the context length. It supports the MOE architecture and support the tool calling. So this is very important for the agentic AI as the model to support the agentic AI. But what DeepSeek version 4 require to support this very important feature, because they actually innovated at the hybrid attention, the architecture. They have the CSA and heavy the compressed attention. These two kinds of compression, two kinds of attention in their overall architecture. They also use the heterogeneous KV cache mechanism. They also use the mixed precision, mix the FP4 and FP8 together, and also a lot of new kernel and runtime optimization. So that's why it really can run very fast, okay? But because this requires the optimization, it brings the deployment on different hardware very difficult. Why? Because today, only very top-end AI chips have the FP4 and FP8 support. Even for Hopper from NVIDIA, it only supports the FP8. It didn't support the FP4, okay? Even for Hopper. And it will require the device, single device has larger than 80 gigabyte memory, okay? A lot of the current, not the high-end GPU device, it only supports the 64 gigabyte memory, not the 80 gigabyte memory. And also, its open source model still coupled with some specific hardware backend, CUDA, okay? So, we do want to run this frontier open model on different hardware. So we need a portable way to allow this model to run on different hardware. So our methodology is because we have built the open computer stack in the past 3 years, led by BAI, work together with Peking University, Tsinghua University, and a lot of academic research institute in China and also global, together with a lot of chipset companies together. Okay, actually Huawei and NVIDIA, they are also contributing to this stack. Yeah. Okay, so we today already support more than 30 AI chipsets and different type of chipset. And in the core part, it is our compiler. Very important is the compiler to support the different architecture. We have the very big operator libraries, framework, and plugin and tools. So back to the DeepSeek version 4, because actually, yes, we have some collaboration with DeepSeek so that we can have the chance to get the model a little bit earlier. And we found that really if we want to migrate it onto different chipsets, to help DeepSeek to migrate onto different chipsets, we do need to solve a lot of technical issues, okay? So, because we have the FlagOS, that means with the FlagGems, this is the operator library, we can cover the full operator replacement to replace all the CUDA and Thailand library. We have the KernelGen, that is the tool to automatically generate the code for the new algorithm. Yes, this time they have 5 new kernels from DeepSeek, which is totally new. So we use this tool to very quickly, just half-day, generate all the required new kernel for all the different backends. Later, Dr. Tao Jian, he will introduce this part. Very important, we also have the compiler, the FlagTree compiler, which is already the compiler support the most chipsets in the world. And we also have the VRM plugin. VRM support the very high efficient inference. That is the high efficient inference engine. And but it lack of the multi backend support. So we developed the unified plugin so that we can allow all this multi backend support capability can plug into the VRM in the very unified way. Okay, we are also working on the SGLang support. Yeah. And other FlagCX is help us to do the O-group prioritization to solve the issue of the memory bound and also the flag release. Okay, so because of all this, we can migrate the DeepSeek V4 onto the different chipsets in just 1 or 2 days. A little bit more is FlagGems. Today, it has become the largest multi-chip Triton operator library in the world. And it already become part of the PyTorch. That means that in PyTorch ecosystem, very broad ecosystem today, besides the CUDA library, FlagGems is the other library, open source, and support the different hardware, okay? So if you want to run the AI algorithm, large model on the other chipset and look for different library besides the CUDA, you can directly go to use the FlagGems. Besides that, we also extended FlagGems into other domain libraries, okay? So for the DeepSeek, yes, we use this one to totally replace the 67 CUDA and Thailand operators for DeepSeek. And also the support a lot of optimization. We also extend the Triton language to Triton language extension, Triton at TLE, and a lot of others, okay? The other thing I want to mention is this very important for us is since we actually solving the issue of n multiplied by m, this very complex issue. Suppose we have n different chipsets, but today's large model, you will run it with the different framework. You will run it with the transformers, PyTorch, or VRM, or SGLang, or in training it is the Metron, or TE, or others. A lot of different framework, thousands of models, okay? So in the old way, it is different chipset vendor, they will heavily hack different framework in their own way. So in our open compute way, we actually developed the whole plug-in, the unified plug-in the system, so that we can have more unified way to plug into the VLM, Echelon, PyTorch, Metron, TE, or VIL, that is the reinforcement learning framework. So that by using this unified plugin, you don't need to change the code. Each time when the new model come up, if you run it on the different hardware, just use the plugin, then the migration will be very, very easily. Yeah. But this work, we do need, for FlagOS community, we do need to collaborate with this framework community. So that means currently we are working with VLM community to contribute our unified plugin. We are working with PyTorch community to contribute our unified plugin. We also working with Metron and Transformer engine community that is maintained by NVIDIA to contribute our unified plugin. And we are very glad that each of these communities, they do know that this importance. So the next one, actually, I didn't put is Echelon. We are now developing it, and maybe mid of this month, we will have the first version come out. And today, that's why today we also invite the Echelon's developer to introduce the Echelon. Okay. And this is what we have done. Yes, we have the chance to collaborate with DeepSeek, so that we a little bit earlier to get the model, and really just 1 or 2 days finish the migration to migrate the latest DeepSeek version 4 onto 10 different AI chipsets, including the Flash version and Pro version. You will see that for example, the Pro version, it is the 1.6 or 1.8 trillion parameter. This is a huge, huge open source weight. And today, yes, most of the chipsets we deal with don't have the FP4. So our way to do that is turn it into the INT8 or FP8 so that we can use less number of server to run up this very latest model. Yeah, so you can see when this is the different precision after our migration. Okay, this is the name of the chipset platform. And we also open source the one-stop code for this DeepSeek version 4. And so you can directly go to this link, can see all the, not only the inference code to support these things, but also the tools to do the conversion, the precision conversion, the quantization, and the other things. And the other thing very important is on the Hugging Face, you can search the flag release organization, and you will see that we already open source more than 120 migrated models. And you can see all the DeepSeek version 4 with the different hardware names. So that means that if you today have the one hardware with the name, for example, Mutex or Amstrad or NVIDIA or Huawei's, just search the name of the hardware and also the name of the model. You can directly download that. Then just 3 steps, you can launch the image and start the inference, okay? You don't need to do the migration again because we already finished that for you and test that for you. Actually, DeepSeek version 4, just the latest one we have done. In the last 2 or 3 months, we already finished the support for Qwen 3.6, Mini CPM, Mini Max, this very latest model for a lot of different chips, okay? And the one thing is important I mentioned is KernelGen. It is the agentic system for this AI operator auto-generate, the code generation. The very special for it is it's not just for 1 or 2 type of chipset. It's for different, a lot of different backend chipset. So that means with this tool, people can use the language to describe the algorithm. Then it will help you to generate the code, generate the test case, and in the backend, it really link on the real hardware. So it will do the precision and speed up the testing. If not satisfied the performance, then again, it will help you to continue the optimization on the real hardware. So today's competition, you can use this one to help you to do that. How to use this one, what's the key innovation and value, you can listen to Dr. Tao Jian's talk later in this workshop, okay? And besides, since we can see that with the agentic AI, people will have more and more need to optimize the hardware, optimize the inference workload, migrate the model onto different hardware platforms. So we also wrap our FlagOS capability into skills. So you can download the skills from our link on the GitHub, and it already can very easily connect to your Cloud Code or the Open Code or any agentic system. Yeah. I want to skip this one. Okay. Besides the open compute, for the agentic AI, we also need the open evaluation and governance, because it really is not just the run, but because it automatically executes your system. Is this trustworthy, or is this safe, or is this efficient enough? So that we do need an evaluation, new type of evaluation to do that. So in today's talk, workshop, we also invite Eclipse, we also invite Dr. Gaber, we also invite other experts to discuss this evaluation and governance together, okay? And FlagOS, actually, we have, this is a whole stack to solve the issue of open compute. Today, we have a lot of contributors, also have the download, weekly download have more than the 10,000. It's not a huge number because it's the software stack. It's not like the model. So very close to the hardware, so that's why usually for these kinds of open source project, you won't have suddenly a large download number. But we are glad that we today already have a lot of chipset company working with us. Yeah. And we also actively to work with the open community and standard. For example, we work with the ITU to make the unified communication library become the ITU international standard. And also we work with PyTorch and Eclipse. And very important for this one is we also launched the Global Open Computer Initiative for AI, because in last year, actually it started from the GOSIM. We look for today in the global, in China, US, or other place, when we upgrade the hardware, the existing hardware usually underutilized. Can we group those underutilized of different vendors, group them together and provide low price or even the free to the developing region, so that they can also have the chance to have the AI education and participate in AI innovation. So that is the idea, to group those underutilized hardware in any place in the world and provide a unified user interface, user experience to the students in developing region. So in the past 1 year, we work together with the United Nations, with, of course, FlagOS, and Peking University, and others. And of course, we work together with African Union, ASRIC. This is the council responsible for Africa, the 50 countries' education. And we implement the first program already. And in last month, we have launched the China Africa AI Talent Development Program, finished the teacher education. Those teachers come from more than 10 different countries from Africa. And yes, we provide this open compute online lab powered by FlagOS. Actually, the hardware AI device is more than 100 AI devices, come from 3 different vendors. Yeah. So we provide them this free resource so that they can have the chance to assess that, design the homework, and now they already back to Africa. And second half this year, they will launch their class in Africa by using this technology and the resource behind that. And we intend to have broader collaboration to have this collaboration in global. And okay, for today's forum, we have a lot of discussion around these 3 different topics. And again, we today have the challenge for 24 hours challenge. And again, I put the URL here if you have the interest to participate. And yeah, so I think today's forum or today's workshop is actually is an invitation. And we want to build open compute and open evaluation together for the agentic AI. Thank you.
So any questions? Okay. Please.
So, if I understand correctly, it will run on every chip, not NVIDIA, but also Chinese chips supported, and so it's an interoperability layer for AI in general.
Yeah.
Okay, thank you.
Yeah,
Great.
actually, this interoperability is very important. So that's why we decide to unify the plugin for VLLM unified plugin for HGLang. So that kind of unified plugin is a kind of interoperability. Also, we define the unified communication library, FlagOS, that is for the communication side, the networking side, to allow the different chipsets can talk to each other. And also, we design the IR, the intermediate represent layer for the compiler side, so that it can unify the design when we're facing the different hardware architecture. So yes, we do need to define the different interoperability. Thank you.
Yeah, please. Sorry. Okay. 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 Thank you. Okay. Thank you. That's me. Yeah. Okay, and the next topic I will share with you the new project we contribute to the Eclipse Foundation. Yeah, that's named the Pen Eval. Yeah. So this is about the story from 5 years ago. That the initial project name is the FlagOS is our original name, and we contribute to the Eclipse Foundation. Yeah. Actually, 5 years ago, at that time, the ChatGPT just come out, and we think about how to evaluate the large language model, and we have this built this from scratch. Yeah. And this project just announced in the Eclipse Foundation last week in Brussels. From the OCS event, which is the biggest event of the Eclipse Foundation. Yeah. So as you can see, according to the research of the Stanford AI research report in this year, we can see that the capability of the large language model grows very rapidly. Yeah. This is the 3 times each year the growth capability, and many of the models come out from the industry, and so in China this number is even more than this number. Yeah. So when all these important large language model become to in our daily life, in our implement system, for example, in our robotics, in a car, in our daily life. So also, many of these large language models will come to the public area. For example, in a public system, for example, in the current system, something like that. So this is very relevant to our life, daily life. So this is the story of the FlagOS. Actually, we start from the 2022. At that time, we released the first version of the FlagOS. And then we have many of the capabilities come out with this, for example, we have some debate system, and we have some with the multiple model, large language model, and recently, and we also have this in the robotic system. Yeah. So this, you can see many of the versions. Also, the platforms come out with the FlagOS system. And also we have some, we also published some leaderboard together with Hugging Face in the past years. And as FlagOS is a complete AI evaluation system. So, for example, we have a multimodal framework. We have the Chinese large language models dataset inside. That is very different to other evaluation systems in the world. And also, we have some debate system to compete, and we have some we have some survey system deployed in our platform. Yeah. Also, we joined the effort of the IEEE to the P 34 and 19 this standards development. So there are three dimensions of the evaluation model. Yeah, task capacity and task and metrics. Yeah. So each metric we have different elements. So this is a full cycle of the FlagEval system for including the framework and evaluation tools and methodology and standardization development and the open platform. So actually we are now building this together with the Equus Foundation for the PenEval edition. Yeah. And we are now doing the progress, doing the paperwork with the Equus Foundation. Yeah, for the evaluation pipeline, this is end-to-end cycle to do this. So, for example, we have to start from define and then serve the API, the FlagEval service system that we can access it from a web system. And then we start evaluation with many of the evaluator types for our purpose. Yeah. And then we get a score from the system and compare to the leaderboard, and we got a complete report outside from this. And this is for the multimodal evaluation framework. We also developed many of the evaluation tasks, and we have 13 evaluator types and 4 model catalogs for the multimodal large language models. So also we have some safety evaluation suite. This is a complex system which includes many of the elements. For example, the prompt test and the video content evaluation. We also have an automated generation pipeline for this system. And now we also support many of the other language, not only the Chinese. We now support English, Arabic, Korean, and many other languages. So now also in Chinese we have developed many of the large language leaderboards, not only in Hugging Face, also published in other mass platforms. So from the behind the evaluation system, we need to build many of the data sets. This includes some kinds of the data sets we have developed. So in Europe, in the PenEval system, we will develop with these data sets to compliance with the Europe rules and laws locally. So after 5 years construction, we now have evaluated more than 300 models, and we have many of the 14 evaluated types, and many of the catalogs of the large language models. And we, in our daily life, for example, just mentioned in our model migration, we also use this tool to evaluate our daily work to make sure the large language model work properly. So in the we also have some standardization work and international collaboration works with the industries. In the IEEE standards, we are the initiate and co-chair of this working group. And for the Chinese national standards, we are the main co-founder of these standards. And also we are work with the global partnership to work with the, for example, the Singapore MDA standards and other Asian countries. Yeah, so why we contribute this project to the Europe, to the Eclipse Foundation, in the one hand, we found that in Europe and the EU AI Act actually have a lot of impact to the industry. For example, as we all know that this all of these constraints must be done before this September to have the sandbox system, and we are very happy to have this system to contribute to the Eclipse Foundation and develop a new platform for the Europe to use. So actually, we started to discuss this from the last year in here to think about the collaboration with the Eclipse Foundation, and this project started with the last 6 months. Yeah. So we have 2 track models for this open source collaboration models. So actually, not only in the original track, we have the pan-eval track in the Eclipse Foundation, and in this part we share the same basic rules and basic data sets and basic documentations. Yeah. And also we will follow the community rules to build together to set up data sets and the rules which complies with the Europe AI Act. So in this model, then we can descend the risk of the governance and share the innovation, and then many of the Europe large language models have their evaluation system to make sure this complies with the AI Act. So it is very important that the pan-eval is the initial and the very beginning open source project of the Eclipse Foundation's AI working group, and in this foundation working model, we will is a fully community working model, and this is a fully open source work model. So now we are doing some final paperwork and some code scanning, and we will deploy the a new version FlagOS system to the Europe. And we also have some collaborations, and we have started with some of the work that later Dr. Gabor will share his topics. Yeah, we have some start some collaboration with the Hungarian universities and institutions. Yeah, so this is since it's a fully open project, we welcome anyone to join this to the project. And actually, we will have this published in the GitHub in this. Also, you can now find our project in the Eclipse Foundation's website, eclipse.dev/paneval. Yeah, so that's the whole story of from the FlagOS to the PanEval project. Yeah, thank you. Yeah, and then let's welcome Professor Dr. Gabor to share. Yeah, okay.
你们不用换麦吗？你们不用换麦啊？我麦不是麦不是在那个刚才讲的那个瑜伽垫上。
Okay, it works. Good afternoon, ladies and gentlemen. Welcome on my behalf too to this panel, to this workshop, and followed by the panel. And let me express my gratitude to GOSIM, to Eclipse, to Bai for being here, and thank you very much for the two presentations. Music to my ear. Thank you, Jean-Hoa. Thank you, Kigang. I would really like to pick up the thread from when you have spoken so far. We have just heard two important layers of the story. Yes. Why agentic systems or any AI systems require evaluation, and why governance and compliance matter. And let me advance one of the thesis of this talk, which is perhaps not new to you. If data is the oil of the 21st century, then trust is the infrastructure in which that oil data can function. And I think evaluation will help us to build that trust environment. I would also like to connect this morning's keynote speech by Sir Timothy Gowers, the mathematician. In mathematics, he reminded us that we do not want only a correct proof. We want insight, and we want the path of reasoning to become more transparent and motivated. We want to see the motivations. I think the same question appears in high-trust public domains. In culture, education, and heritage, a domain I have been working in for 25 years, we do not only need correct-looking answers. We need traceable answers, accountable sources, contextual reliability, and the ability to say, I don't know. My contribution today is the deployment-facing bridge. My central question is simple. Where and how do we test whether AI systems are actually ready for responsible use in the real world? I will argue that benchmark performance alone is not enough. and that place-based evaluation testbeds can help connect technical capability on the one hand with trustworthy deployment in high-trust public domains. So this is the outline of my talk, and some of my talk I will reserve for the panel, so discussion at the end, so please stay if you can. I will proceed in 4 steps. First, I will briefly explain why benchmark success does not yet mean deployability. Second, I will propose place-based evaluation testbeds as the missing layer between evaluation and deployment. And third, I will use Tihany in Hungary as a concrete reference environment. And finally, I will return to what this may offer to Panaval, Eclipse, BAAI, and open collaboration more broadly. The thread running through this talk is this: evaluation should not begin only after a chatbot or AI companion is finished, just as the AI Act of Europe prescribes. If we want meaningful Panaval-style assessment later, the system must be evaluation ready by the design, by its very design, from the very beginning. So, the session logic so far is already very strong. We have heard that agentic systems require new evaluation. We have heard that open infrastructure can make scalable and vendor-neutral evaluation possible. And we have heard that governance sets the conditions for trust. What I would like to add is the missing layer: real-world deployment environments. In other words, not only how to evaluate systems in principle, but where to evaluate them under realistic public-facing conditions, especially in high-trust domains. This morning someone said to me at breakfast in the hotel that evaluation becomes difficult once we move beyond code. I replied half-jokingly that for me the real world is the easier part. I'm not coming from the code world, as you probably know from my language. Perhaps that is exactly why I'm here, to bring real-world public domain environments into the evaluation conversation, not as noise, but as the condition under which trust must be tested. So, benchmarks are important. They tell us about task performance, comparative model strength, and progress on specific defined tasks. But the real deployment requires more. It requires traceability, auditability. It requires robustness, and safe abstention when the answer is unsupported. It requires documentation readiness and contextual reliability. So the real question is not only can the model answer, but rather can the system be trusted in context. This is especially important in public-facing high-trust environments, where the very institutions that are offering and using these tools, these chatbots, must be able to stand behind the system's behavior. After all, museums, heritage sites, and the institutions connected with knowledge governance are the credible places for the public. If the chatbots, if the tools they are using are not credible, they are putting their credibility at stake. Here, the connection again with the morning keynote is direct. In mathematics, a correct proof without insight may not be enough. In public domain AI, a fluent answer without a visible pathway from source, context, and governance to the answer is also not enough. We need contextual reliability. So open evaluation needs realistic testbeds, kind of like stress tests. Have I said it right? Stress test, that's a different word. So if an AI system can function in such contexts as heritage, education, culture, but you can name others, then it will be reliable. So this is the core shift I want to propose. We need evaluation environments, not only evaluation metrics. Public-facing AI should be assessed in environments where institutional context, user diversity, ambiguity, and accountability are part of the evaluation conditions. Place-based evaluation testbeds provide that missing layer. They make it possible to test system behavior under realistic public-facing constraints. So this is not an argument against benchmarks. It is an argument for extending evaluation into real environments where deployment conditions actually matter. We also heard this morning in the other keynote how data science remains foundational for AI. The quality, structure, and preparation of data are not secondary detail. For high-trust public domains, I would add that curated, governed, and situated knowledge is the condition for trustworthy AI. So the evaluation of the model and the very construction of the knowledge environment must therefore be connected. So let me offer a governed deployment pattern, and this is where I come to the core of my talk. It begins with field encounter. Experience precedes modeling. Analog first contact with real site, with real people, with real materials, and real context. Let me pause here because this first step is not decorative. It is not because I come from culture and education that I propose this. In high-trust public domains, fieldwork is not simply outreach. It is upstream knowledge governance. If we simply scrape existing documents and connect them to a chatbot, we only test document retrieval. But we want to test responsible deployment, we need to know how real people encounter the place, what students, teachers, local experts, and institutions observe, ask, misunderstand sometimes, contest, and correct. It's a process. Fieldwork is how the real world enters the system before the model enters the world. These situated questions and observations and gaps do not go directly into the AI system. They enter a co-curation process, that's the second box, and only then do they become part of a governed knowledge layer with curated sources, with provenance, with access logic and correction pathways. On top of this sits the AI companion, which retrieves and answers and synthesizes under controlled conditions. Finally, a supervised feedback loop allows questions, gaps, and corrections to improve the system over time. On the bottom of the slide, you see some Latin words, which I just flag here, that this place-based is part of a larger framework. It began as an attempt, what I call chronotoma, it began as an attempt to translate digital twin logic into the heritage and cultural context. In industry, a digital twin usually models a physical system for monitoring, simulation, and optimization. But a heritage place or any public place is not only a physical system, it is also layered time, that's why chronos, human meaning, that's why logos, living practice, and material reality. So the twin cannot be only spatial or sensor-based. It must become a governed semantic world model. So the chronotoma structures a place through topos, chronos, logos, and materia, place, time, meaning, and material systems. In practical AI terms, this becomes a structured grounding layer or a knowledge graph. The goal is not to digitize heritage as mere content, but to carry analog cultural practices into algorithmic environments as structured, traceable, and governed knowledge. So why place-based? Because places are dense relational environment. A chatbot, a large language model, works with data. But data, if it is only text, it is flat. You need the relationship between the data, and chronotoma can give that relationality. So places concentrate institutions, narratives and users, materials and infrastructures, and contested meanings. Taken together, these form complex relational environment that makes places ideal for testing exactly the kind of things that matter for trustworthy deployment. Hallucination, abstention, provenance, traceability, contextual robustness, and public-facing reliability. So place is not simply content. Place is an evaluation environment in which system behavior can be tested under realistic conditions. To connect again with the mathematical analogy, in mathematics, a transparent proof makes a reasoning path, the very process, visible. In heritage and public domain, public cultural knowledge, a place-based grounding layer makes the pathway from place, source, meaning, and governance to answer the more visible. And therefore, this is near Lake Balaton. You see Lake Balaton, a patch of Lake Balaton here. You see a village. This is a peninsula. You see the Tihany Benedictine Abbey, a small town, and you see what is called an inner lake, which is not connected to Lake Balaton. It's a separate lake within the environment, within the peninsula. Tihany is useful not because it's picturesque, but because it's a genuinely high-trust environment, a cultural landscape with multiple institutions and communities, multilingual public-facing use cases, and the intersection of culture, education, water, and the environment. It therefore allows us to test deployment-facing questions in a realistic way. The fieldwork phase produces real inquiry patterns. Co-curation turns them into governed knowledge, and the AI companion retrieves from that layer. And the Peneval-style evaluation scenario that you have just presented is not merely a site-specific chatbot idea. The Peneval scenario can test whether this improves traceability, safe extension, contextual robustness, and provenance and documentation readiness. Why does this matter? Because Tihany is not merely a site-specific chatbot idea. I have done those before, thanks to open source, by the way, in Lake Turkana in Kenya and elsewhere in Hungary. But it also creates a connection to a global framework in the UN Ocean Decade project. And it is not only tourism. The point is, again, public interest AI in real-world socio-cultural and socio-ecological environment. And as I said, if data is the oil of the 21st century, then trust is the infrastructure in which that data can function at all. So, coming towards the end, I suggest to move towards an open evaluation framework that includes deployment readiness. If Peneval and Eclipse are building vendor-neutral open evaluation frameworks, and if BAAI brings strong experience from FlagOS and multi-dimensional model evaluation, then this ecosystem we are building here and aligning the different threads must benefit from high-trust real-world use cases, deployment-facing evaluation scenarios, and place-based test beds that link infrastructure, evaluation, governance, and deployment sites. My suggestion is that the next step for open evaluation is not only better benchmarks, but realistic test beds where technical capability and societal trust can be assessed together. After all, this is the encounter between the human and the machine. And when we evaluate, we need to evaluate that encounter as well. And in practical cooperation terms, the chatbot or AI companion does not need to be built by the evaluation platform, but it must be designed to be evaluated at the beginning. So logging, traces, retrieval pathways, test question categories, baselines, and success criteria should be aligned from the very beginning. Build separately and evaluate together, but design for evaluation from day one. Thank you very much, and I would be glad to continue the discussion on how place-based governance-first evaluation environments could contribute to bridging Carnival, BAI, Eclipse-related collaboration, and broader open source ecosystem building for high trust AI deployment. My hope is that Tihon in Hungary can become a small but concrete bridge from FlagOS methodology through pan-EVA governance to real world trusted AI deployment in Europe and beyond. I'm also working with colleagues in Africa and other parts of India, and beyond Eclipse as its platform for cooperation. Thank you very much for your attention, and I'm open to your questions.
Any questions? Yeah. We're looking forward to Hungary to be our first test bed. Yeah. Okay. Any questions? Yeah. Okay. Then we will go to the next topic. And the next topic is from our college from BAI, Dr. Tao Jian, to share the KernelGen.
Okay, hello everyone. Nice to meet you. The next topic is about our automatic kernel generation tool. We call it KernelGen. And it had been mentioned by Ms. Lin before. And now I'll show you some technical details. And I'll share our exploration and practice in our research. And this tool plays a great role in the adaptation process for DeepSeek waveform model. And I'll show you the detail. Okay, my presentation includes 4 parts. First, I'll show you some background about this domain kernel generation. This is a subdomain of AI infrastructure. And I'll show you some related works. Second, I'll introduce the design of our work of KernelGen, and then I'll show you some experience of use the kernel generation tool in the real world scenarios. Finally, I'll briefly tell you about some future work that we are planning to do or we are currently working on. Okay, now let me introduce the background for you about the kernel generation. Okay, from an algorithm engineering perspective, language models use many functions during training and inference, such as addition, subtraction, multiplication, and divisions, or more complex ones like softmax and attentions. These can all be called the operators. We can see these common operators in PyTorch in a form of PyTorch APIs. So an operator is a computational unit that can be optimized independently. For example, APIs in the PyTorch framework, and they serve as the building blocks of model training and inference. Okay, to go a little deeper, and we'll look at what happens when we use a PyTorch API. For a PyTorch function, its call graph is shown in the left picture. Usually, under the Python function, there is a CUDA function or a Triton function. A Triton function is Triton is a domain-specific language, open source from OpenAI. It's just like the CUDA. You can use it to programming parallel program for GPU. Sorry. These things are there are okay. Under the PyTorch operator, there are some CUDA functions or Triton functions. They are responsible for launching some parallel computation in the device. I mean, in the GPU device. These things are run on the GPU, are called kernels, and they are important concepts in the AI infrastructure field. For more details about how PyTorch call functions, you can refer to the middle picture. There are some details about PyTorch source code involving the operator calling graph. There is a namespace called Aten. It is a middle namespace. Aten means a tensor library. It is a bridge connecting the Python code and the CUDA code, or you can or CPP code. The CUDA is plug-in of C++. And PyTorch default kernel implementation under hood uses the CUDA language. Okay, and the right picture, I'll show you the simplest CUDA code. It includes two parts. The one part is the wrapper. It's running on the CPU, and another part is the kernel function, which is running on the host. I mean, running on the GPU device. The kernel function is scheduled by the wrapper function. Okay. Now we have known that kernel generation bridges the gap between high-level mathematical abstraction and high-performance hardware computation. So, compared to general purpose programming, GPU programming is more difficult. Parallel programming makes the logic more complex and debugging harder. As the language model algorithm developing, there are many operators need to be developed and need to be debugged, need to be optimized. So this makes the operator development task with high technical barrier and also a huge amount of work. So it's not only a technical work, it's also a labor work. Therefore, generating kernels using large language model or agent has become a natural direction. This is a very new direction, but it also developing very quickly. So I will show you some excellent works in this area. For example, there are three typical works. The first is kernel bench from Stanford. This is the first benchmark for kernel generation. They released it about last year, and this benchmark including 300 operator problems. And the middle one is the Triton language model from Tsinghua University. It uses some dataset to fine-tune language model for this domain-specific task. Okay, the picture on the right comes from the NVIDIA team. They released a blog. They built a simple workflow to let the model generate kernels and debug the error. And they achieve good results. Okay, next is the second part. I will introduce you our exploration and the practice for kernel generation. Firstly, a few months ago, we released the first version of our tool, KernelGen. You can try it at this link, kernelgen.flagos.io. And in the first version, our tool has these features supporting for natural language descriptions. You can describe your functionality to our tools, and the tools will give you a high performance kernel. And then it can automatic verify and test the kernel and support for multiple backend chips. And then in our first version, we developed a workflow with language model. In the development, we refer to the experience of operator developers and provide some tools for the language model, include a unified verifier and a knowledge base. This picture below is an example of usage in the whole workflow. We provide the model with a reference implementation as a baseline. Usually it is built by the PyTorch. In addition, we collected over 200 Triton-related repositories and over 400 CUDA-related repositories as a knowledge base for the language model to refer to when generate code. The final feature is cross-platform Triton operator support. Thanks to FlagOS Unified Triton compiler, KernelGen can seamlessly generate and test kernel on different devices. During this process, the developer or the user do not need to do any extra environment setup. This greatly improves the development efficiency. Below are 5 chips vendors that we already supported, including Huawei Ascend and Haiguang and Morse Rand, Elevator, and Matex. These are all chips vendors from China. Okay, the right picture shows the pipeline of the entire multi-chip support. The unified Triton compiler named FlagTree, which is a part of FlagOS, is the most important part of the whole system. It compiles the same Triton code into the binary code that can work on different hardware backends. Okay, after introducing the main feature, let's look at the updates in KernelGen version 2. In the previous version, we used a large language model plus workflow approach. But now, in general purpose programming, code agent has become very useful and powerful, such as Cloud Code or Codex or Gemini CLI. In our research, we also found that code agents work better than workflows in kernel generation. They are more flexible. However, we also discovered an important drawback. So, shouldn't we leverage them for specific tasks instead of building something custom? The answer is yes, but no, because they cannot keep working toward a single goal for a long time. After several context compression, it's easy for them to lose focus to the goal. So we created a workflow based on a code agent such as Cloud Code or Codex or Gemini CLI, and you can use any language model such as Cloud or GPT or DeepSeek V4. For parts that need deterministic control, we use a control script to handle the logic. For the generation process, then needs free creation, we let the code agent do its best. So we design a directory structure for the agent so that it can understand on previous versions and avoid losing focus on the goal. The new version of KernelGen enhances the generation capability for various AI chip kernels. The correctness improved over 30% overall, and the performance reached more than 3 times. Okay, next I'll show you our experience using it in the real world. First, let me introduce the evaluation result of KernelGen on benchmark. Since current benchmark do not have a complex operator or multi-chip evaluation support, so we proposed KernelGen bench. The report will come soon. It 18 operators. It means PyTorch operators, and 15 plus operators, and 15 VLM operators. It means some fused kernels. And the KernelGen match has more test case and has the shapes come from real-world language model inference stage. It also supports multi-chip evaluation. The table in the upper right shows a comparison with Cloud Code. You can see that our method achieves better results in time usage, in token usage, and the final speedup. In real-world usage, we have contribute almost 200 PyTorch operators to FlagOS, which is the largest open source Triton operator library under FlagOS. This has greatly expanded the number of our operator library. And another important experience is the adaptation of the DeepSeek V4 model. FlagOS is a Triton-based software stack, but some operators in the DeepSeek source code, transformer version, they have some new kernel developed use Talon. This is a new language for GPU programming. So we use KernelGen, helped us quickly implement the Triton versions of these operators, and we achieve better performance than the original Talon implementation. Here is the 5 operators. For example, at P bar, matrix multiplication and sparse attention and Hadamard transform. Okay, when we use KernelGen for operator development, we first do a setup. We create some tool files, including test files, benchmark files, and reference implementation, usually based on PyTorch or CUDA or Talon. The KernelGen keeps optimizing the kernel until the performance meets the goal speed up on it reaches the maximum number of optimizing runs. The right picture shows the optimization record for 2 operators from DeepSeek model. both of them ends up with production level trading operators. The first one is a hardmark transform, and the second one is sparse attention. Finally, I will briefly introduce some feature work. First, we will continue to expand our KernelGen bench. Currently, for multi-chip evaluation, we only support PyTorch operators, or it means ATEN operators, but not VRM operators. Secondly, we hope to add more powerful profiling tools to KernelGen agent. For example, on NVIDIA, we will firstly consider NVIDIA NCU. It means NVIDIA N-site compute. On other chips, we will add corresponding tools with the same functionality. Finally, we hope to develop KernelGen into a self-involving agent that can continuously accumulate more operator development knowledge, so that its capabilities become stronger and stronger, and the knowledge base become bigger and bigger. That's all for my presentation. Thank you for listening.
Okay. Any questions? I have a suggestion. How about you open the homepage of the KernelGen and show up? Okay. Any questions? Please.
Thank you very much. I came from financial background, so my question is, what can we estimate the cost saving overall from the KernelGen?
I will show you the evaluation picture. You can see the upper right table. We compare the KernelGen version 2 with Cloud Code, and its token usage is 10,000, and the Cloud Code is 20,000. And the time usage also is shorter, and the final speed up is greater than Cloud Code. And this version of comparison, we use the same cloud model, but actually you can use another model more cheaper than cloud model, such as the DeepSeek V4. We have adapted the DeepSeek V4 on FlagOS software stack, so you can use this model for the backend. And in our experiment, DeepSeek is more cheaper and almost same speed up. Yeah.
Okay. Another background is in the past the professional programmers to handwrite the operators. Yeah, we used to, more than 2 years to write about 200 operators. And now with this use this tool, we get maybe 100 operators in 1 month. That's a comparison for you.
Okay, and the KernelGen is open source, so we provide a MCP server for users. You can use it in Cloud Code or in VS Code or Cursor, such as IDE. Yeah, and we have a website for experience. You can click the KernelGen.flagos.io, for the usage. Thank you.
Okay. Okay. Thank you. Thank you, Dr. Okay. Our next topic, let's welcome Zhipeng to share. He comes from the LFAI and Data Foundation.
Okay, bonjour à tous. I'm very happy to be invited by BAI and the FlagOS community to give a talk today. So I'll be just introduce like two open source communities. One is called Omni AI. It's very new. We created that at the middle of last year. The other one is sort of long established LFN data foundation. Okay, so about me, I'm currently serve as the board chair at the LFN Data Foundation. I've been leading open source AI ecosystem team at Huawei as well for many years, and yeah, a couple other positions. Yeah, so the first one is called Omni AI. So Omni AI is a NPU, Ascend NPU based sort of end-to-end inference stack. We open sourced at the middle of last year. We kind of like encouraged and inspired by DeepSeek Open Source Week last year, if you guys remember. So we decided to open source basically everything we did on Huawei's Ascend chip for the performance optimization for DeepSeek R1 0324, that version. Yeah, so this is the newest addition to our AI open source ecosystem. So one of the core projects is called OmniInfer. So think of it as a building upon VLM and SGLang, which we have a speaker later today. Building upon those inference frameworks, so we add the patches for the high performance enhancement on NPU. So we add a lot of patches. On top of the framework, we have the Omni proxy. So it's Nginx based. So basically help you to scale all the PD disaggregation, all the inference cluster scaling you want to do. And below the framework level, so usually with our releases, we release together with our sort of our counterpart to CUDA, we call Ken. So we release with our the most up-to-date version of the Ken drivers and a lot of the kernels together. So yeah, that's all those things make it into one, what we call OmniInfer. So basically, it's a one-stop shop. If you have a Ascend NPU hardware and want to do inference on the most like up-to-date open source LLMs, you can use that. So it's all open source. You can search it on GitHub. It's mirrored on many sites. So another like characteristics from our team is that we actually have a lot of research scientists on our team. So research report publication is also like in addition to code development is part of team's job. So we have released 3 reports so far on archive. You're welcome to check them out. So we have one describing the OmniInfer, like how we design the stack. The second one is about how we basically change the multiplication to addition to accelerate a lot of flash attention MACML computations on NPU. And the third one is, I think, another attention and FFN disaggregation optimizations we have experimented in collaboration with University of Hong Kong. So we, so mostly the community is in China, of course, but we are looking forward to build a global community. As I said, so we are on GitHub. There's like nothing really like too Chinese specific. So you're welcome to check out the code. Even if you don't have assigned NPU hardwares, you can check out the code to see how things work. Yeah. Okay, the second one. So LLVA data is actually the oldest AI-specific open source foundation under Linux Foundation, which is now, I think, the largest flagship open source foundation globally. So LLVA Data Foundation was established, I think, 2018. Back then it was called LLF Deep Learning. So the name was changed a couple times afterwards, but you get the idea that as a AI open source foundation, it lived through the days of, back in 2018, it was still TensorFlow, right? TensorFlow was still a big thing. So that was the framework wars days, and into nowadays is everything LLM. So it has lived through like 4 or 5 major transitions in our field. It hosts a lot of projects from Europe, and with the emphasis on, of course, AI and data sets. So here are a couple star projects or loved by developers. Odex has transitioned to PyTorch Foundation, just recently announced, I think last month, also at Station F at the PyTorch, the first PyTorchCon Europe. We also have Milvus, which is a vector database, Docklink from Red Hat, Delta Lake, and Kedro. Kedro is a good agent. I think it's an open source agent framework. And we also have a model openness framework, which there's a team called Generate AI Commons. So the team there developed this evaluation framework to help you to evaluate which open source LLMs are indeed open source. And also MOV had a lot of collaboration with BAI. For example, their Aquila LLM was one of the first to be tested. So we have a lot of foundations, a lot of projects. So this is like one view of, to see like where LFA data foundation fits in the like larger landscape. Okay, now I'm gonna introduce like 2 new projects that I'm personally leading in LFA Foundation. One of the sub-communities we call Open Model Initiative. Okay, Open Model Initiative was actually established, I think, last year. The team established OMI back then. Like stable diffusion was still a thing. Stability AI was still running, so they want to do a open source version of SD3. If you remember, that was like kind of enthusiastic things to do. So after 1 year, everything I think goes into the end of life cycle. So I talked to the team leader, and yeah, so take over as the technical steering committee lead to start the stage 2 of Open Model Initiative. So the stage 2, we have a lot of new ideas. So one of is do the multi-model speed run. So I will give us like deep dive talk on this tomorrow. You're welcome to check it out tomorrow as well. So I don't have like much more background at our talk today. So basically, speedrun, I think, especially in this era of agentic coding, you don't have to hand code anymore, basically. But speedrun is actually a really good way of an open source community to first discuss the idea and then implement, and just like showing off in a rundown. So long story short, we kind of kick-started the world first multi-model speedrun in early February this year. So I worked with a couple like core developers from the CompSci lab from Germany and India, North America. It was a truly global effort. So now we have 2 benchmarks. Basically, we have the very first image run. It was just a like very basic setup to solicit the submissions. The second one was from a community called LMMS Lab. It mostly encompass Singapore University. So they submitted NanoVIM, which was quite amazing. So here you can see this is our first speed run. We have a basic rule set. We tells all the potential submitters like what the rules are. As you can see, very simple setup. And on the right hand side, that was like our baseline. So that was a run done by Sway on REG, based on REG paper. NanoVIM is another interesting submission from the Singapore's LMMS lab. So it focused on a minimal setup of VM train on 8 H100, so pretty minimum setup. And they also experienced it with agent, so they called the co-scientist. I think hallucinations is still pretty high, but it was quite fun. Okay, the next new project we experimented under Open Model Initiative, well, are the agents, the claws. But our angle was quite unique. So one of the like interesting paper caught my eye at the end of last year. It's called Recursive Language Model from the team from MIT. I think it basically helps you to pre-process large or long context at the host site. I think this is a interesting proposition. It does not like necessarily offer an end solution to the long context language model problem, but it definitely helped. So that was like one of the things we want to experiment with. So we write a Zeek-based implementation of RLM. We call it Omni RLM. So for those of you who are not familiar with Zeek, so Rust is the new generation to C++. Zeek is the new generation to C, basically. So personally, I've been following Zeek for quite a long time. I like Zeek's design philosophy, so I just tried it out with Zeek. So we write this very high-performance minimum RLM package implementation, and using that, we write also a Zeek-based we call OmniClaw. Well, it's sort of a claw. So OmniClaw is a like really bare minimum because we just use it for our daily development work, which mostly are POC, not production heavy, that sort of jobs which you are mostly use codecs and cloud. But for our kind of job, we want to write our own agent, coding agent. It was quite fun. And since our little agent used RLM, and we start to experiment with really nice long context processing, especially with coding. Okay, I talk about lots of projects. If you are interested, at the left-hand side is the OmniInfer I just mentioned. So NPU-based inference optimization end-to-end stack, purely open source. On the right-hand side is the LFN Data Foundation projects I just mentioned. All the speedrun, you can check it out. And our agent, very small and rudimental experiment. And yeah, feel free to check it out, use yourself, and talk to me if you are interested. Okay, thank you very much. Merci.
Okay, thank you. Any questions? Yeah. Okay, thank you, Zheng. Yeah, actually, we see a lot of projects come to the FAI and Data Foundation. Yeah, and the next topic, let's welcome ST Lance. Yeah, actually, we see a lot of improvements in the performance of the ST Lance project. Yeah.
Yeah, hello everyone. I'm Xingyuan and I'm a co-contributor to the Strong project. So in this presentation, I will introduce some kinds of overview and some recent updates we made in this inference engine. So yeah, first of all, so what is Strong? Maybe some of you have never heard of this, let's say, project, but it is widely used across different big companies and different, let's say, AI products. So I believe you are using kinds of different, like AI service, not the OpenAI or the Anthropic, but you may have used like GLN, like Kimi, and all this model at the back of this model are our framework. Where so what is this? We are making we're using our effort to make this model running faster and faster. So here is the overview. So Strong is the very first open source system that nearly matches the performance of DeepSeek's official blog. Maybe you have some kinds of memory that about 1 year ago when DeepSeek V3 is released, and at that time, no one could match the DeepSeek's own inference speed. You can see this model is very big, this model is very strong, but although it's big and strong, it's open source, but you cannot get or match the performance on other third-party inference platform other than the DeepSeek's own official endpoint. That's how the gap and how we resolve it. So basically, we just use different technologies that I will introduce to you later to match this official performance. And here are some numbers you can check. Yeah, here are some numbers. And also, we have some multi-hardware support. You can see from here are some blocks. So we support the NVIDIA cards, and we support the AMD cards. We also do support to TPU, which is JAX. And we also support the Intel CPU inference. And yeah, our community is very big and it's all growing very fast. So we are working closely with lots of big companies and startups and even schools, colleges, to improve or cooperate together to other help them to build some applications on top of our framework or working together to improve our framework or make the model run too fast. And here are some recent features I want to highlight to you. The first one is zero overhead speculative decoding, where speculative decoding is a technique that can hugely improve the decoding speed of the AI. And we, as a prefix, which is zero overhead, which means we do something to our scheduler to make the speculative decoding could enjoy or use the performance speed up of the one feature called the zero overhead scheduling. So it can get about 10 to 20% of speed up, even combined with the original zero overhead scheduling. And the second one is Strong diffusion, which is not too standalone, but another project of Strong which working on the diffusion generation, which just generates, we call it multimodal gen because it could generate, not only generate the text, but also generate the images and videos and audios. And also we have the SpecWorks V0.2, which is a draft model training framework. The draft model is used during the speculative decoding. So which is help like the third-party help model that could use together with the target model, which is the original big large language model, to speed up the inference. And we have the mini Echelon. It's a kind of lightweight yet high performance framework that it's very tiny, so it's about like 100, well over 100 code lines than our main repo, but could reach about like 90% of the performance. And it's mainly for like research purpose, like if you want to build some prototype or research projects on top of Echelon, instead of working on the main repo that's very messy, there's lots of duplicated, or not duplicate, sorry, we don't have not that kind of duplicate. It's complex code base. You can just work on this minimized version to do your own integration or do your own patches. And we have EPD distribution for the large-scale multimodal vision language model serving. And here is some explanation and some architecture of the zero overhead speculative coding. So the first is which is this term, which is the zero overhead, which is term representative. So basically, when we do normal scheduling, we have to sync the GPU with CPU when we finish one batch of inference. But with this overlap scheduling, we just use some techniques to let two batches of inference running like overlap, so they can just let's say canceling the CPU overhead, which make the inference speed even much more faster. And we combine this technique with the speculative coding. And originally there are kinds of technical differences, difficulties, we cannot combine them together. But now we just combine them and make them work together, so it's even more faster. And also the Echelon diffusion, we just make it to combine with our original strength, which is high-speed text inference engine, and we just build on top of it. So, and we just immigrate it to the diffusion engine, which we reach between 1.2 and to 5.9 times speed for image and video generation. Some of you may hear of some normal diffusion models like CDance, and we are working on some open source diffusion models that can achieve about 90% of the performance, not percent, sorry, of 90% of the quality, but yeah, it's totally free and you can deploy on your own racks, and it's more faster. You don't need to wait for a long time to get a batch of video or image output. And also we have the spec model and spec verge. So spec model, as its name, is basically some a set or a bundle of Java model we train by ourselves. Also cooperate with some companies. So thanks to these companies, they just train their Java model using our framework and also open source it. So thanks for that. And so basically it's a native Echelon integration for the speculative decoding of the native. Basically, when you are using this framework, you just train a Java model, and you can just use this Java model in Echelon and seamlessly. And next is mini Echelon. Here are some of the architectures, and I'm not like going to very deep tech today, but it's just an example. And next, let's talk about the roadmap of our Q2. So basically, the first And very important thing is that we are working to make all of our optimizations orthogonal. So originally, as we have lots of features, and these features are like implemented separately. So there must be some blockers that make them hard or buggy to working together. But makes them orthogonal are technically possible, but implement in the term of implementation it's hard to that. But we are working hard to making them working orthogonally and not affect others like performance. So also the usability is very important. We are working on to make our framework working very well across different hardware like NVIDIA and AMD TPU and CPU. And also we are working on some kernels implementation. Yeah, we have kernels introduced before I remember. This time I'm just showing to we are working on the next gen hardware optimization, including the GB300 and GB200, and yeah. And also we have the multimodal and RL. We are working on the diffusion model support, and we are also working on the RL framework integration. So you know, RL, the rollout staging are basically the effort of the inference engine. Oh, and also we have a prototype that's working on the diffusions reinforcement learning, which is we want to make the some of you may hear about the GPT image 2. It could output very not perfect but very good like text quality, which means it can write text in GPT image 2. That's thanks to the OpenAI's own post-training, which is the RL framework, and we are also working on to make it open source. And next are some code refactors, basically just increase the usability of our framework to make it more stable. So we are working on scheduler refactor, which is currently most of the code in our framework are written by Python. But Python is not it's easy to write, but actually it's not that like production ready, let's say. So we are working on to refactor it and write it in Rust. And you know, Rust is a very like production ready language and could go to more like high concurrency. And we also want to refactor our heavy cache management to make it just let you guys using the framework and extra and less or one. And we have speculative decoding abstraction, basically just increase different kinds of speculative decoding method. And PD disaggregation, which is very important project that in large-scale production deployment, we are always using a PD disaggregation, and we are working on it to make it more usable, more performance. And the API server, which is kind of the front end, we just make it more like OpenAI compatible, which is we are working on the response API, and the other like check completion we want to is more like usable. And basically that's the core refactors. And also for the parallelism, so basically we have TP, DP, and EP working well. We are also working on some more like pipeline parallel and context parallelism, and to make them more production ready. And we have the DP attention and the DWDP, and also working on the performance improvement. And other is basically the different hardware improvement. And multimodal and RI I just introduced above, and yeah, and also reliability and release. Reliability is a very, very, very important thing. We want you to use our framework without experiencing lots of bugs. And yeah, basically that's the roadmap. And if you have any questions, and welcome to ask.
Okay, thank you, Xin. Any questions? Yeah, actually, I have two questions. Yeah, the first, what's the target hardware of the mini SG long? Is the edge?
So basically, it's lightweight. It's very, very lightweight. The code line is just about like 101. So the target is basically if you want to do some explorations on the inference engine. Let's say some colleagues, they want to like try their own ideas on the production wise inference engine. They are hard to edit, like the min replace from or the VLM. So we just provide this as an option for them to they can write the code more easily and integrate their own ideas more easily.
Okay. And the second question is actually your last page. So actually, we, as you may know, that our team is also working on the SGLong plugin.
Mm-hmm.
Yeah. I think we can release in a couple of months. Yeah, in the future. Yeah, couple of months. Cool. Yeah. So I think we can have some collaboration in the parallelism and the cross hardware.
Yeah, we are open to collaboration and contribution. Yeah. And also, I haven't written it in slides, but we just upload our very first lectures in deeplearning.ai. So with Andrew Wu. So you can just go to that website and watch our tutorials, and that's very beginner friendly. If you don't have any experience about the inference engine or even the GPU, you can still watch that and get lots of knowledge about it.
Okay.
Thank you.
Yeah, any questions from, yeah. Okay. Okay, thank you.
Thank you very much.
Yeah, okay. And the next part is we have a panel section that we let's welcome Ms. Lin and Dr. Gabriel and Serge. Yeah. This is a discussion about that from the open compute to the open evaluation and even to the open governance. Yeah. Let's welcome.
Wait a minute. Since we actually in my since they are uploading your presentation, so, yeah. Okay, today we will have, I will invite Dr. Gabriel and Dr. Serge, the two to participate in the panel. Since Dr. Serge hasn't present his idea or songs in this workshop, so I might invite Dr. Serge to present yours first, then we will have the panel. Serge to present yours first. Serge to present yours first. Yours.
Thank you. Okay. Good afternoon, everyone. Bon après-midi à tous. I hope that you are not too tired, because we have seen lots of very interesting presentation up to now. So I know this is a bit tired to listen to a very diverse presentation from lots of different speakers. So I want to discuss a bit my perspective for the panel that we will have in, I guess, in 5-10 minutes. So I have a very small set of slides. I have only 3 slides. I'm also working for the United Nations, like Gabor, but in another organization that is maybe very well known, the United Nations University. And I've been working the last 6 years in one of the institutes of UNU located in Macau. And I relocated to France actually since the last 2 weeks. So I'm still working a little bit with this institution. So today I want to present a little bit the idea around digital public goods. I don't know if you know what is digital public goods? No? Okay. A little bit, thank you. I will come back to the definition later. And I will present basically some ideas that we are discussing inside a report that we will launch during another very big UN event that will happen in New York in June, so the UN Open Source Week. So we launch this report about digital public goods and AI. And this is a work that is commissioned by the Asian Development Bank. Okay, so what are digital public goods? So, and I will give you the definition of the UN that you can find in one of the reports of the UN Roadmap for Digital Cooperation. And this is basically a little bit more than open source software. So it's open source software, open data, open AI models, open standards, and open contents that adhere to privacy and to other applicable laws and best practices, do not harm by design, this is very important, and will help us to attain the SDGs. So basically, this is open source that will help us to attain the SDGs. Okay? And there is a foundation, an alliance called DPGA, so Digital Public Goods Alliance, that was founded in 2019, who is a consortium of partners, so people from governments, NGOs, private sectors. And they have made this list of 9 indicators. And if you want to qualify your software or your open content, data or your model as a DPG, you have to satisfy this list of indicators. So basically, you have to be sustainable. Okay, so follow the SDGs. You have to be open, have an open license for sure. Have a clear ownership, platform independence, good documentation. You should be able to extract the data inside your software. Follow the laws. Follow the best practice, and do not harm humans, do not harm the planet by design, okay? This is very important. And more recently, DPGA and other partners, they were interested to understand if we can also qualify AI system as DPG. And if you look at the list of the software that they qualify until now, they have a registry of software, and there is something like 200, and I think I put the numbers somewhere, 241 verified open software, open data, etc., that are verified as these digital public goods, but only 3 of them are AI systems, actually, or AI models. Because it's very difficult. You know, AI, there are lots of issues because you have to open not only your software, but also the weight, so the code, the weight, the data that you use to train your systems. So it's very difficult to define exactly what is an AI DPG. And this is what we have tried to do in our report. You can read the report when it will be released in June, in 1 month. And okay, I don't have time to go through all the risks and the challenges when you are using AI DPGs, but I just want to finish my short presentation on open compute because this is the topic of this session. And I want to push two ideas. The first idea is that we can, because we have three categories for DPGs right now. So a DPG can be an open software, open content, or open, what is the third one? I don't remember the third one. So there's three categories. And why not adding one more category? Because when we try to run AI systems, the system might be open, you might be open source, but if you don't have the capabilities to run your AI systems, nothing happens. And I'm thinking about the context of low-income countries. They have the talents, they can access to open source software, they have maybe data sets, but they're not able to run AI systems because they don't have the compute capability. So why not considering open compute as a new category for DPG, okay? And we have examples of that. We have already existing, so people who try to pull together computer infrastructures. So there are projects in different countries to do that. There's yesterday I was in another panel about open token, so the idea that we can maybe try to give token to people who need token to do something interesting in the context of AI. Maybe FlagOS also is an initiative like that. So we see more and more initiative of considering, of giving access to computer infrastructures, so this idea of open compute. And the second idea that I want to push is so governance, it's about governance, so how we can govern this. And I think we have seen recently lots of papers about the idea of compute governance. And I think this is a very interesting idea because when people are talking about AI governance, there are lots of ideas, lots of principles, but most of them are not really applicable. It's very difficult to have something concrete at the end. If we are talking about compute governance, it's much more easy because you can trace, you can put some device inside your hardware to trace how much token you have used. You can monitor that. You can maybe decide that there is a limit to use if you want to be sustainable and not impact the environment. So I think this idea of open compute is something very interesting. The idea of compute governance is very interesting, that specific idea, broader idea of open compute. That's it for my very short presentation, and maybe we can discuss more in Singapore and Yonghua about that. Thank you.
Okay, thank you. So, please.
Okay, then I think there's the three orders. We have the three in total. Yeah, Gable, please. Yeah. I think you can move.
这个圆桌你们怎么录啊？我不知道呀。
哦。
Okay, as I don't want to occupy so much time, so I think in today's panel we will have the two rounds of the questions. One is common and one is specific. So for the common question, since in today's panel, in today's workshop, we already discussed a lot around the Agentic AI, and yes, Agentic AI will require actually more than the open source of the model. It do need the open compute, open evaluation, and governance, and also the community. So from your perspective, which one is the most urgent missing place or missing pieces to build a health and global collaboration for the Agentic AI? Which one would be more urgent piece for the open compute, open evaluation, governance of the community? Yeah. So who do we want to go first? Yes.
I think, yeah, talking as you and Gaia, I will maybe say governance first is important, even if I'm a tech guy, so governance is very important. especially in the context of countries who don't have access to these compute facilities. So I've been several times in Africa, invited by, you know, there is a very big conference called Deep Learning in Daba, and there are, you can see, it's very incredible. It's a bit like that, but even bigger, with lots of dynamic people, very dynamic people of the community, local communities, and so there's a big pool of talents, open source talents in these countries, but unfortunately, if you don't give them access to these kind of things, it's an issue. So I think Open Compute might play a role here. Because I remember a few years ago when I was in Cameroon I gave to my students some NVIDIA cards at that time because it was the only way for them to do some interesting things with AI algorithm. Now maybe I have to give them some tokens so they can do some actual work. Yeah.
Okay, thank you, Serge. We will come back to you for the Open Compute later. Then, Gable, how is your idea or your thought? Which one is the missing piece? Yeah.
Well, thank you very much for allowing me to express myself again. Well, let me answer from the perspective of the high trust domains rather than from the technical architecture. Okay. My main point would be this, and I try to articulate this in my talk. As AI systems become more agentic, as they do not only generate answers, but plan, call tools, sequence tasks, and support action. So evaluation has to move from model performance to system behavior in context. So that's why I suggested place-based AI. And in my talk, I argued that benchmark success does not equal deployability. So benchmarks remain essential, but real-world deployment matters. So the key question is no longer, can the model answer? The key question becomes, can the whole system be trusted in context? Governance for sure, as Serge already suggested. Open compute, yeah, we'll come back to that. But for agentic AI, this becomes even more urgent. You have heard the news, OpenClaw, and there are others. If a system can call tools, retrieve information, recommend action, or interacts with real institutional workflows, then we need to evaluate the whole action chain. What was the task? What plan was generated? Which tools were called? What evidence it used? What did the system rely on? Did the system rely on uncertain information, as systems often do? Could a human supervisor understand, interrupt, correct, or reverse the process? This is, by and large, the same question that Sir Anthony Gowers asked about mathematics this morning. So, beyond accuracy, I would highlight 7 evaluation dimensions, and I will be quick. Traceability of action chains, tool use reliability, which comes with compute, with open compute as well, provenance and evidence quality, safe abstention, corrigibility and human oversight. Item 6, governance readiness. So is the system documented, accountable, updatable, and institutionally maintainable? And 7th, public context robustness. So does the system behave reliably with diverse users, ambiguous questions, and multilingual contexts in a socially sensitive way? I think maybe I will come back later with the other points.
So actually, yeah, sure, please.
Yeah, sure. So I totally agree with what you suggest, and I think it's if you look, for example, at the indicators that I mentioned, the DPGA indicators about what is digital public goods, they just focus on the creation of the software, not the deployment. And I think this is something missing, and this in the report that we will release, we mentioned that as something very important. We have to think about what happens at the deployment stage, especially when you have this kind of interaction with people. And for me, it's very important to involve the people in the design of AI solutions. And in my lab, we have been working on the idea of participatory research about participatory modeling, so the idea of involving people in the designs of AI models, for example.
So actually, I think a big difference from the large model to the agentic AI is for the large model, it's easier for us to do the benchmark evaluation because usually it's just API, just the question and answer to check if the answer is correct or not because it didn't include any execution. But for the agentic AI, it includes the execution. So that's why, yes, we think that the deployment stage, the evaluation for the deployment stage is very important, and also the evaluation in the real world is also very important. But it turns out that the cost for the evaluation might grow up very, very fast, and also since if we want to really have this evaluation in the real world, it might have much less efficiency, or it really time consume, or even the labor consume. So, yeah, any idea? Yeah, that's my second question for you, Dr. Gabriel.
Well, a bit of humanities background. Ovidius, the Latin poet, had a line which started like "Principiis obsta," that is, resist at the beginning, otherwise you will spend much more energy, let's paraphrase like this, on curing the disease. So upstream, like Chinese medicine, I think traditional Chinese medicine. So you need to intervene upstream in the process, as you say, at the design of the chatbot, rather than fixing the problems later. Okay? So if your design, in the design of the chatbot, you involve communities, you are conscious of the context in which you're working, then the costs of evaluation will be much less. The cost that you will have to spend on fixing the problems later will be much less. So this is important not only for ethical AI, as UNESCO's recommendation, but I think it is important from a business point of view. And one other thing, Serge, you have pointed out, I think we are on the very same wavelength here about involving communities in the design of digital tools. I have been doing this, I call it the Bartok 4.0 methodology, and I can talk about it a lot, but the point is also about the sovereignty of narrative, okay? We call that digital cultural sovereignty. So when you go into a community context and you are using the data that is provided to you by the community, you have to respect their ownership of the data, the narrative sovereignty that they may want to retain over the data. In Europe, this can be called GDPR, but I think it's a universal principle. The example I used to give is that I don't want to see myself on an AI-generated video sitting in the lab of Stalin shaking the hands of Hitler. You wouldn't want that either. So it's a shocking example, but you can see images like that. So I think it's important that your image, your narrative, you should be capable of controlling what happens to that. So when you go into a community context, you have to be aware of that. And the other principle is fair share. So when there is revenue generated by that product, be it symbolic or be it a market revenue, then that revenue should be shared in a fair manner. So those are the two caveats I would put in. Principiis obsta and fair share.
Okay, yeah. So later we will open for one or two more questions from the audience here. Yeah, so you can prepare any of your questions you want to raise. But let me ask the second question to Dr. Serge is back to the open compute, right? You mentioned, agree with you. Actually, I remember in some of the ITU conference last year, and I remember on the stage, Africa representative, they said that when we discuss if the standard should include AI safety into the standard or not, but for Africa, they don't have the talent, they don't have enough talent, they very lack of the talent for AI, and also the infrastructure, the compute for AI. So So that's why it triggered us for FlagOS Open Compute. We first choose the Africa to start our small project. But at that time, lucky for us is because we happen to know some organization within the United Nations, so we can create a connection to the AU, African Union, and some organization under that. So that's how we can start some of our project. But for the broader world, actually we know that a lot of places, actually they also need this kinds of help. So for the digital for good, public good, digital public good platform, how can it play a bigger role for that? And if the organization like us or other organizations, they want to contribute that, how can we work together to make this open compute more easier and spread in the world?
Yes, it's a difficult question. So I think there are multiple things to do. You need to, first of all, maybe just explain to the people, because they are not aware of this kind of framework, and they are not aware that they can play a role also. So it's as a contributor in open source software, for example. So I think training and learning is also very important. I'm more, for me, I'm really interested by bottom-up approach, so trying to generate the interest and trying to, and you say that maybe there is not enough talents, for example, in AI, in Africa, for example. I'm not completely sure about that, because when I was in Cameroon, I spent 2 years and a half in Cameroon, I see lots of talents, but all these talents, they go to France or the US, or they are not, because it's not possible for them to do anything good at the end, because they have not only they have no access to token, but they have sometimes they have electricity cuts, no access to internet, so it's very difficult. Another solution, if you want to go, if you want to stay on the technical solution, is also to use edge AI. So it's not to try to do something in the cloud, but try to use specific localized solutions and try to run them in smaller infrastructure, so in local solutions. And I know that nowadays it's you can do lots of things on using IoT devices, things like that.
Thank you. So, since still there are a lot of audience here, any of you want to raise 1 or 2 questions to our panelists? Yeah.
I know there is an organization named Digital Public Goods Alliance. Yeah. So is this part of the UN, and how do you know how the alliance work?
It's a kind of consortium, and actually it was, if I understand correctly, it's a kind of spin-off of the UN, so it's people from UNICEF and other people from UN who have established this consortium. So now it's an open consortium, so you can, every governments, every companies can apply, NGOs can apply to the consortium, and you can participate to the work of this consortium. Okay. So it's completely open.
Okay, thank you. Thank you.
From our audience. Hey, please.
Well, excellent chance to speak with you guys, since you have a different backgrounds compared with other workshops. A short and funny conversation is noontime when I had the lunch with several young ladies who's studying from the University of Sorbonne, and when I look at their eyes, I can see the exciting, because they told the ladies told the young student told me, I'm so excited to see the open source topic, open computing topics, and this kind of openness with the AI. So we're so happy to see the future of AI. So at that time being, I spoke to respond to them. Honestly, even though I'm not that pessimism, but with the working experience for the decades that AI is not a fair game, even in the future. So it is always the game between, say, stronger players all over the world. So in this circumstance, how can we imagine the open computing, the open evaluation, or the open governance happen, occur someday in the future? The question for that is, when we're talking about some other, say, territories like Africa and some areas, you are correct. When we're talking about the, by example, from say, égalité for the computing or for the AI, I don't think it's going to happen here. It's like the conflicts with the energy, like the power, the water, these natural resources. So I don't believe that will happen in a fair and open way. So I would like to listen to your guys' say advice, not rather than the Chinese herbs, to respond to my question. Thank you.
Thank you, Xu.
It's a very interesting question, and I feel the same when I discuss with young people, the very enthusiastic Western people or Chinese people. They are the same, or French. It's always the same. They are very they like this idea of using AI system for everything. But I have to remind them that there are also lots of issues, environmental issues, access to the resources. The fact that most of the system have lots of barriers, so I agree with you that it's difficult to push this idea of openness, but I think we definitely need to push this idea of openness because it's if we don't do that, we will lose lots of things, and when we are talking about openness, it's not only open source or open compute, but the whole idea of also of open science, the fact that you have to make everything in transparency, things should be reproducible. So I think we should fight for this idea of all this idea of openness in the future. But I don't know exactly how, but I guess this is what we are trying to do inside different UN organizations. But yeah. Sorry, it's not really an answer. But
well, thank you for the question. Coming from a UNESCO background, UNESCO is about open science, open source, online education, open. Okay, open. If you really want to make it, contested, open doesn't mean free. Open means accessible. And then you have to compose with innovation and creation. So if, copyright, if you don't have some system of protecting your intellectual property, then there will be no innovation, the industry will be not driven, etc., etc. So you have to compose with different stakeholders. But open is definitely, if you want a historic analogy, think about printing. AI is actually, I think, a more radical shift in civilization than printing was. I think it's comparable to the move from orality to writing, maybe even more important, because that was still between humans, and now we are moving to the machine. So when printing was introduced, it took about a century to develop, publishing houses, copyright, the whole system. This will go much faster now, and we are making the first steps. We are somewhere where, another analogy, if you allow me, just, I'm not sure if it fits, but just to make you think of potato. When potato was imported to Europe in the Renaissance, the aristocracy started to eat it raw, cut it and eat raw. It didn't do good to them. It took about a few years to understand how to use potato and how to make it nourishing. And now we discovered that potato may not be good for the brain and we should replace it with some other vegetable from China, actually. So I'm quoting these examples just to show you that what is now happening is not unprecedented when a new thing appears. And as the other keynote said today, it is not just a change of tools, it's a change of system. I don't know, it was the third speaker, I think, from Huawei, who put this very, very neatly on the table. We are witnessing a civilizational change, which will make a lot of changes. And of course, there will be interest for closed AI systems, only for business, only for profit, and there will be those who want open, the academia usually wants open, debatable, public, etc. And these forces will inevitably play out like in a battlefield, so to say, if you want to sound antagonistic. And we need to create platforms like Eclipse, like this conference, GOSIM, where this could be discussed, interests aligned, and common action developed together. Thank you.
Thank you. Yeah, I want to comment at last is open compute is actually not only to allow the model run on different hardware, then to let the people have lower cost access. But actually, additionally have two more points. One is to protect your today's investment, and the other is to encourage your future innovation. To protect your today's investment means that today, for example, if you look at NVIDIA, in the past 2 or 3 years have already deployed a lot of the hardware for the A100 or Hopper series. But now the high-end frontier models all focus on the GB2400 or GB300. So a little bit out of date hardware already start to underutilize. So how to protect today's existing investment? Don't waste that kind of investment is a big question, okay? The second is encourage future innovation. Let's say, okay, for each chipset, from the design to small volume the manufacturing, it will cost around maybe close to 1 billion RMB, maybe 0.1 billion in Europe, okay? That's a big money. If there's no ecosystem software can allow a lot of model can run on the new hardware, then that means that even we invest on the new generation of the hardware, then have no way to have a large scale deployment. Then the investor, they will not again and again to invest. So the another value for the open compute with the FlagOS means that we want to decouple the innovation of the system software with the hardware. That means that we want a lot of system software innovation, include the Agilon, VRM, those kind of things, can very easily to be used on different hardware. So it can allow us to feel free to do the more aggressive innovation in the hardware innovation. You know today, for the chipset, the power efficiency compared with our brain, the power efficiency is, our brain is 10,000 times more power efficient compared with today's chipsets still. So still we need a lot of aggressive hardware architecture innovation, very disruptive hardware architecture. So that's why open compute actually on the other way is we want to build a unified open source stack so that we allow the different architecture easily adapt onto this stack, then they can benefit from the more downstream the value of the software. Then the hardware innovation itself can feel free to go ahead very aggressively. So, thank you. So, I want to ask our panelists just one sentence as a close for today's panel. The one sentence you want to share, or you want to call for, or you want to speak, the most important one sentence. I didn't tell them before for this.
Actually, I have one sentence.
Okay.
I can prepare one sentence. Yeah, I can. In 10 years, AI digital public sorry, in 10 years, AI digital public goods won't be the dream, they will be the default, but the fight will have shift from whether to build openly to who gets to define what open really means. So it's a kind of answer for the question also.
May I respond to that? If you want to achieve that, you must streamline this discussion into the post-2030 agenda setting, okay? So this has to be streamlined into mainline policy discourse so it ends up being adopted in New York. The sentence that struck me most this morning, which I liked very much, from Bill Wren, we can outsource thinking, and that can cause some problem about cognitive impoverishment and lack of autonomy, but true, we can outsource thinking, but we cannot outsource understanding. And I think that's important to retain. And let me quote myself, but maybe I didn't invent this, but you know this famous saying that data is the oil of the 21st century, and trust, I think, is the infrastructure in which that oil can circulate. Thank you.
Okay, thank you. Yeah. And then we come to the last section, and also I think it's an exciting section. Yeah. We have the one moment, and we have the Dr. Tao Jian to share the to share the 24-hour challenge champion, the challenge. 日本还是？
这都不用去前面给加了，就是。
Okay, thanks for your patience. It's me again. And the final topic today is our 24-hour operator competition. Yeah, we have a hackathon from this afternoon to tomorrow's afternoon. And I'll show you the rules and the three operator problems. First, I will introduce the general rules of our operator hackathon, and then I'll explain the details of these operators to you. Finally, I'll go over the evaluation rules of the competition. Okay. We have known that kernel's performance play a vital role in the training and inference efficiency of model. So, and writing high performance for operators is a challenge for a developer, even you are an expert of this domain. So the goal of our competition is to design high performance operators for different backend chips within 24 hours. And there are three operators problems in totally, and we have a $500 reward for you if you win the competition, and we'll tomorrow afternoon we'll announce who is the winner. Okay. In this competition, we have 3 operators, and so we have 3 leaderboards. Each winner will obtain $500, and so totally $1,500 reward you will get. Okay, the timeline is showing on the left. It starts at 4 p.m. It means you can now submit your solution for now, and to end at 4 p.m. tomorrow. And the final ranking will be based on the leaderboard after its end, and the competition use a bounty mode. 3 problems with $500 cash prize. Okay. And the evaluation matrix is focused on 2 dimensions. First is the kernel's correctness, and second is performance. Okay, so what you will do is only implement a high-performance kernel. Maybe you think that you are not expert of this domain, but just try it. You can send our website into the ChatGPT on Cloud Code and tell it that help me to obtain the $500 prize. Yeah, that's okay. Just try it. And next, I'll show you the 3 operator problems. These kernels are we selected from the DeepSeek V4 inference stage. The first is sparse attention. In this kernel, you need to implement a top-K sparse attention kernel that compute attention by gathering a subset of K-value pairs. Also, you need to end the attention-seek mechanisms. It means you need to including the first one of 4 tokens when you gather the subset. You need to include the first tokens. On the right picture, we show you our reference implementation. This is implementation based on PyTorch. You can see that the logic of this kernel is actually is not complex, but if you want to get a high performance implementation, it's still a challenge for you, for me, and for you. Okay. Next is the second kernel named MHC. You should this kernel is also come from DeepSeek groups, and they released this kernel to replace the ResNet in language model. You should to implement a field kernel for multi-stream, mixed-stream, and doubly stochastic matrix projection. If you don't know the logic or the mathematic abstraction of this kernel, you could to check the reference implementation based on PyTorch. Next, I'll show you the documents on the website. First, I'll show you the third kernel problems. The third kernel is fused MOE. This is famous and important kernels in large language model inference because most of current models are using MOE structure. And this kernel including several things, including softmax routing and top key selection and getting up and down GIM. GIM means matrix multiplication. and something else. You can also learn the logic in our reference implementation. Okay, and there are some core challenges. If you're interested in, you can check it in our website. And next is evaluation method. We will compute the average speed up on the 5 chips. If you got a mismatch result on certain chips, you will got a 0 score on these chips. And the following is our workload to evaluate. You can also find it in our computation website. Okay, that is the computation introduction. And now I'll show you a demo how to submit your solution to obtain the $500. Okay, you need to open our website KernelGen.FlagOS.io and let me enlarge it. Yeah. Okay. There is you need to click this kernel challenge and to into this page, and there is our introduction about the computation, and this is the total price pool. It's 30,000, and because we have 2 tracks, one is the GOSIM track, one is the online track. You guys just choose the GOSIM tracks. It's okay. And we have 5 hardware platforms and 3 kernels problems and 24 hours. Yeah. Next is our problems. The sparse attention and DeepSeek MHC and fused MOE. Okay, if you want to submit your solution, you just click this view details, and first you find the kernel descriptions and this is the kernel sorry. Okay. This is the kernel descriptions and this is our test workload. You can just test the kernel on your own device. You can use this test workload. And then is the reference implementation we provided, and you can say it is PyTorch-based code. And this is a function signature. You must use the same input arguments in your own chat kernel. This is a mathematical logic written by PyTorch. Okay, this is a kernel description. Then, if you want to submit your solution, you just click here, and there is a timeline, and then you just put your code into here, and I'll show you this. I have write the solution, a reference. I use a reference implementation. It also works, but we will check if you use Triton. Also, if you use this solution, you click open, and then you submit the code. Okay, how to get this code? You can just open the ChatGPT on Cloud Code and ask for help. And then, if you want to know the leaderboard, you can click here. And okay, this is my solution. I submitted before. Because I use a reference implementation, so I got speed up is 1. The average is almost 1. So, and because I choose, I'm GOSIM check, so there is a signature GOSIM. And this is somebody I don't know online, and he has submit a solution that got this score. But you cannot view the code, other players' code. Only me have this. Yeah. So you just focus on the average speed up. Okay. So you can see there is not many players now, so it's easy to obtain this $500. We will give you next tomorrow afternoon. Okay, that is our competition hackathon. Thank you very much.
Any problems? Any questions?
Do you have more information on the specific model of graphic cards that will be used to optimize the code, or it must be more of a general solution?
If you want to know more details about the kernel optimized skill, firstly I recommend the paper. The DeepSeek paper, you can, sorry. For example, the DeepSeek has released their MHC paper in archive. So if you want to know the optimized details of this kernel,